Hey folks, I'm Mr. Hartzler and I want to talk to you about factoring and particularly the difference of squares and perfect squares. So let's start off with the difference of squares. We use this one probably more often and the other one's a little bit more intuitive, I think. So a squared minus b squared splits up like this. So this is the formula for it right here. A squared minus b squared, and then we split it up like this. A's in front, b's in back, and then minus and plus. Those are always alternating. But it doesn't matter which order I put these two things in, as long as they're right next to each other and they're being multiplied. All right, so if I have an example like this, first off, it's two terms. So I know it's only either going to be difference of squares, difference of cubes, or sum of cubes. There's no sum of squares, really. So it's going to be one of those three. And because I have a square and a 4, definitely can't be anything with the cubes. So it's going to be this difference of squares. So now I need to figure out what a is and b. And you'll notice my front thing is a squared. So I need to do the opposite of that. What's the square root of all of this? Well, what thing squared will give me the 25? That's going to be a 5. What thing squared gets me x to the 4th? And that's x squared. And then that minus is going to come down here. What thing squared gets me this 16? 4. What thing squared gets me y? That's just y. So now I know my a and my b. My a is the 5x squared and my b is 4y. Now all I have to do is plug all of that in to the formula over here. So let me erase those little arrows I drew. So it splits up, right, with a and then b and b. A is 5x squared, putting that in both spots. And then my b is 4y. And this one's a plus, and that one's a minus. But again, because everything's the same except that sign, if I switch the signs, it's not too big of a deal, right? So nope, I need to keep that square though. If I change that to a minus and this to a plus, it's all still the same. Everything's still good. And that is completely factored there. All right, let's do a little bit more factoring using the difference of two squares. So what thing squared is going to get me the 16? 4. What about that a squared? Just an a. And then what squared is going to get me the 4b squared? 2b, or not 2b, that is the question. All right, and then I know my a, right? It's kind of confusing because there's an a in it, but all of that is a, all of that is my b. So this factors like 4a minus 2b, 4a plus 2b. And you can always verify this by foiling it back out, right? Multiply my first and first, my outer and outer, my inner, and then my last term in each set of parentheses. And you should get back to the original. All right, now this one. This one will get a lot of people. What thing squared gets me a 1? Kind of a trick question because that's still just 1, right? 1 squared is still 1. And then what squared gets me 4x squared? 2x. So that splits up into 1 minus 2x, 1 plus 2x. All right, last problems with difference of squares, and then we're going to move on to one slightly different. Here, I have now 2 letters, and it's getting a little bit ahead of ourselves, but I think this is some good foreshadowing. A squared and b squared, so this is going to be an a and a b, and then that squared will get distributed to both of them. And then for the d, it's just going to be d that gets squared. So a and b go in my first part of both sets of parentheses, and then there's a minus, and then there's a plus, and then the d goes in the back part of both sets of parentheses. Now this bottom one, you could still split this up by saying, okay, 2x squared, and all squared, and then what squared gets me a 100? Ooh, 10. Yeah, almost forgot. And I could do this and keep going, or I could remember that I should always check my GCF first. And this one has a GCF, or a greatest common factor. And I can pull out a 4 from both of these things. So that's now x to the 4th minus 25. All right, awesome. So I'm going to leave that 4 out in front, and then I'm going to factor that set of parentheses. X squared and x squared will get me x to the 4th. 5y and 5y will multiply to get me 25y squared. And then I have to have a plus and a minus. So that is now factored up. Nice. Always check your GCF first, folks. Now, let's look at types of perfect squares. I have one where I'm adding and one where I'm subtracting. But a lot of this formula, you'll notice, is very much like a classic trinomial. So let's do some examples here. First off, which formula is this one going to be like? Number 1 or number 2? Nice job. Number 1. That's the one it's going to be like. So we're going to use that one. So a squared, right? That's still helpful. What squared gets me this thing? Well, 2 squared gets me 4x, and then squared gets me x squared. Awesome. That will help me tell what a is, right? Now I know that a is 2x. Look at the back half, b squared, just like our last stuff. So what squared gets me this 25? Y to the 4th, 5, and y squared, all squared, gets me that same thing. Awesome. So now I can factor this up a little bit. I know it's going to be that first formula. So I checked out my a squared and my b squared, so I can find a and then b. Now I just have to plug it in. 2x and 5y squared. And what sign is going to be in the middle? That one. Plus sign. Awesome. Done. Next one. Oh, this one, I didn't give you the formulas, right? This one is simple enough that we can do our classic. What thing multiplies to give me that 16 and adds to give me the -8? Okay, so 2 and 8, none of that combination is going to work. 4 and 4, okay, that 16 and 8, that seems like it's right, but both of these have to be negative. If I multiply two negatives, I get a positive 16. If I add them, I get a -8. So that's how this one's going to go. X minus 4, x minus 4. Because x's multiplied together get me that x squared. -4's multiplied together get me that positive 16. And if I add -4, I get that -8. But this simplifies because those are both the same thing. I can write it like this. And that still follows our formula. So if you notice, like from our last one, let me go back real quick. We're now doing this second equation. So what squared gets me x squared? X. What squared gets me 16? This is the part you have to be careful because that is just a normal 4. But because that's a negative, that sign there is a negative. So that still leads us to the same conclusion. My A, my B, but I remember because that's a negative, that's a negative. Same answer. Awesome. Two different ways of getting there. Another one. Remember GCF. If I try and factor this like the other one, this whole thing isn't actually a term being squared, right? I have to factor out that negative first, or sorry, that 2 first. So 2x squared minus 8x plus 16. So that is factoring out my GCF. Always look for a GCF first. Now I'm just going to keep bringing that 2 down, and I'm going to factor all of this. What thing squared gets me x? Or what thing squared gets me x squared? X. What thing squared gets me 16? Oh, not a 16, a 4. And then this is a negative, so that's a negative. And then it has to square it. I would still be careful doing this one sometimes, though. This can get a lot of people into trouble because it doesn't always factor like this. I only know it does because we're talking about perfect squares. If we weren't talking about perfect squares, I couldn't necessarily do this. So another way to check this is to still try and factor it like a normal trinomial. So what things multiply to get me 16 and add up to get me -8? The fun thing is that's actually our last problem. So I would guess 4 and 4, but because that's a -8, I know they both had to be negative, and I would put them in there, and x is in the front. Then I would notice that both of these are the same, and I would write them down like this. All right, so be careful trusting the perfect squares. And that is all, folks. Hopefully this was helpful, and hope all of you have a great rest of your day.